Okay, so this is the third video for this week. We're looking at degrees to miles, and then also ETA, which is estimated time of arrival. So on our last video, we found distance. So let me put in our page. Okay, so basically we use the Pythagorean theorem. I'm not going to solve this again, I just put it off to the left. If you want to solve it, you can go back and look at the other video. But basically we came up with the distance of 40.5 degrees. So degrees as a distance doesn't really make much sense. We're used to seeing it in miles, right? So that's what we really want. We want miles. Okay. So let's talk about miles and hurricane tracking. So there are two different kinds of miles. So we have land miles, which are also called statute miles. So a statute, of course, is just like a law or regulation. So a land mile, which is called a statute mile, this is like a regulation length mile. So this was established by some regulation at some point in time, and they said, okay, a mile is 5,280 feet. But then people built boats, and they started exploring the world, and now we have this other thing called a nautical mile. Nautical being, over related to the ocean. So a nautical mile is different than a land mile, and there's a reason. But so a nautical mile is not 5,280 feet, it's 6,076 feet. Say, what? Okay, the reason of this is the nautical mile wasn't based on how far along land you went, right? Because you're in the water. So what they had to do is they based it on the Earth. So if this is the equator, so that's the middle of the Earth, and this is just your vertical, like from the North Pole to the South Pole, then if we go along and we divide this up, so you have like 1 degree, 2 degree, blah, blah, blah. From the equator all the way to the top, that's 90 degrees, right? It's just a normal, so if this is 0 degrees, by the time you get up to here, this is 90 degrees. So what they did is they took the distance from here to here, and they divided it up. So within a degree, you have a certain distance, and this is how they got the nautical mile. So a nautical mile is like this. There are 60 nautical miles for every 1 degree. So 60 miles in 1 degree. So then that's going to give us our conversion factor. But that's also how they came up with this. It turns out that 60 miles, like they call, if you divide up a degree into 60 pieces, then 1 mile is 1/60th of that. That's called a minute. It's really weird. So 1/60th of a degree is called a minute. That's what they call it. And there's a mile for every minute. Okay, so a nautical mile then is 6,076 feet. Okay. So then, okay, we have 40.5 degrees. We want it in miles. So, okay, so now we know that a nautical mile is 6,076 feet. It's different than a land mile, but that's okay. We're just going to call it a mile because for our purposes, usually when they give the speed of a hurricane, they give it in nautical miles per hour anyway. So we're just going to call this our mile. So this is what we're going to use. Da-da-da. What we're also going to use is this. This is our conversion factor. So if we know then that it's 40.5 degrees, and we want to know how far away that is in miles, we just convert. We go, okay, we have 40.5 degrees. We want to know how much it is in miles. And we go, okay, well, 1 degree is 60 nautical miles, right? Our units cancel, so this degree cancels out this degree. So all you do is whatever distance you get, you multiply it by 60. So we have 40.5 times 60. And if we multiply that 40.5 times 60, that gives us 3,137.3 miles. So now we've taken it from degrees to miles. So this is kind of a handy conversion factor. So we know 1 degree equals 60 miles. So you could actually be all slick. Like, let's say you have a friend who lives in San Antonio, and that's like 180 miles away. And you want to go there, but you know your mom's not going to let you because it's too far. And she's all like, you're not allowed to drive further than 5 miles from the house. So you could go, okay, well, Mom, I'm going to go to my friend's house this weekend. Is it okay? And she'd be like, well, how far is your friend's house? And you get slick, right? You know it's 180 miles. But you know that probably your mom doesn't know about miles and degrees. So you go, well, wait a second. There's 60 miles per degree. So if you convert that, 180 divided by 60 is 3. So that's 3 degrees away. So your mom goes, how far away is your friend's house? You go, well, I mean, it's not that far. It's only 3 degrees. If she's not paying attention, you might get away with it. Of course, your mom might be slicker than you think. She might, like, actually know. But anyway, so that's our conversion. So when we calculate our distances, we're going to find them in degrees, but we're going to have to convert to miles. And one of the reasons that we care about that is that that's what we're going to use to figure out how long it's going to take to get here. Okay, so when there's a hurricane out in the Atlantic or in the Gulf, they always give you these updates, and it always tells you the coordinate points, and then it'll also tell you how fast it's moving. So, an average speed for a hurricane might be 11 or 12 miles per hour. Sometimes they're going really, really fast. Sometimes they go really slow. It's the slow ones you have to watch for because then they have time to sit over the warm water and build up strength, right? But okay, so let's say you're in New Orleans. You've got this hurricane out here, and we're just going to pretend like it's headed straight for you. And it's 3,137.3 miles away. We want to know how long it's going to take for it to get there because if there's an evacuation, you want to leave early because otherwise you get stuck in traffic. So you go on to the news and they say, okay, well, it is moving at 13 miles an hour. And we're going to pretend that's nautical miles. A lot of times they'll say wind speed in knots, which is a nautical mile, or they might say, it's moving at 13 knots. Well, we'll just say miles per hour. So now we said a while ago on the other video, we had our little distance formula, distance equals speed times time. We solved it around and we said, okay, well, time is distance divided by speed. So we know how fast it's going. We know how far away it is so that we can figure out our time. So the estimated time that it's going to take, we're just going to take our distance, which is 3,137. 3137. If you hear snoring in the background, it's my dog. She's on the couch. That's miles away. And then it's going 13 miles per hour, so we're going to divide it by 13 miles per hour. Our miles cancel out, and that's going to give us our number of hours. So that's just, that ends up being 241.3 hours. And then we're going to convert that because I want to know how many days. So I go, days, we go, okay, well, there are 24 hours in a day. So I go 241.3 hours. I go, okay, there's 24 hours in one day. And if you wanted to, you could do this all together, like you could do the time and then you could just convert it right from there, but that's okay. So if I divide that out, it's going to be a little over 10. So I go 241.3 divided by 24, that gives me 10.05, so like 10.1 days. So I'm gonna round down. I'm just gonna say, okay, well, that's 10 days. So if the hurricane's that far out and it stays at that speed, then I have 10 days until it gets here. Now you don't want to wait 9 days before you evacuate if you're going to evacuate, because then things will be crazy, but at least you have an estimate. So when we have a hurricane, we're going to track it. We're going to find out how far away it is using Pythagorean Theorem. And then using the speed, then we'll be able to tell when it's going to get here. So we'll do one more. Okay, so let's say I didn't put it on a map. Let's say, okay, we're there. This hurricane's on its way and it's 728 miles away. We went on Channel 2 and Frank Billingsley, the weather guy, said, okay, it's moving at 11 miles per hour. We want to know when it'll get here. So we can say, okay, well, our time is equal to distance divided by speed. In this case, 728 miles divided by 11 miles per hour. And that gives us our speed in hours. Okay, so 728 miles seems like a pretty far away. Like that seems like a pretty big distance, except that if something's moving at 11 miles per hour and it's just keeping on going and it's just going and going and not stopping, then it ends up not being that far away. So if it's that far, going 11 miles an hour, that works out to 66.2 hours. And if I convert that to days, so I have 66.2 hours, and there are 24 hours in one day, then that works out to 2.8 days. So I have less than 3 days to get everything situated or to get all my stuff put together and to evacuate. So our estimated time of arrival then for the storm would be 2.8 days. Okay, that's all I have for this video.